car goes through a turn at 35 miles per hour and has a centripetal acceleration of 5 meters per second squared. What centripetal acceleration would a car need to sustain to make the turn, same turn that is, at 70 miles per hour? I don't know about anyone else, when you read a question like this and you see those miles per hour, does anyone else groan and think, oh, joy, I'm going to have to do conversions. It's going to get annoying, right? But maybe it doesn't have to here, right? Because what is the thing that we're looking at here? We're asked about centripetal acceleration, right? And the formula we have for that is a sub c is equal to v squared over r. But we're comparing two situations where the turn is the same. In other words, the two situations have the same r value. So maybe the way I can look at this is, since, maybe I can say here like, well, if r is equal to a constant, then that implies that the centripetal acceleration is proportional to the speed squared. Oh, so maybe we can do this in terms of proportions, right? Because if I look at this, I can say, well, it went, from 35, it had a centripetal acceleration of 5 meters per second squared, and then it doubled to 70, right? So I think that means it would have to quadruple the acceleration, and 5 times 4 is 20. So I'm saying 20 meters per second squared. Maybe a more formal way I could look at this, though, is I could say, hey, A1 over A2, setting this as a set of proportions here, or stacked set of proportions, is equal to V1 squared over V2 squared. And in that sense, if I say, let's say that, let me just go over here and say, let's say that A2 is equal to 5 meters per second squared. That would mean that V2 is actually equal to the 35 miles per hour. I kind of made the choice of 1 and 2 arbitrary here. And that would mean that V1 in particular is equal to 70 miles per hour. Okay. And if I simply multiply both sides by A2, I wind up with this. And maybe I can even simplify this to just distribute this, this square over the whole fraction there. And that means in terms of numbers, it's 5 meters per second squared times 70 over 35 squared. But 70 over 35 is just 2. 2 squared is 4. 4 times 5 is 20 meters per second squared. And, I'm just kind of showing the fully transparent math process here. But with practice, like I said, I was up here, I think, and I said, I think it's going to be 20 miles per hour. Or maybe it's with practice you recognize, oh, I can just write something like this because I know I'm going to get a bigger acceleration. It's going to scale with a ratio of the velocity, so I better put 70 over 35. Oh, there's a square, I better square it. There's ways to shortcut the process if you practice this and think about the ideas of how proportions work. But there it is, 20 meters per second squared.